Okay. Now let's look at the APIs. Why success or Sai, this is covered in the prerequisites. It gives you easy calculation. So please check the prerequisites. The point number 2, that how to do approximate calculations in system design interview. So yeah, please, no need for okay and thanks. Sorry, but because if you type okay and thanks, then I have to go and manually remove those questions. So it's okay. Yeah. So for APIs, yeah. So the APIs design should come from the requirements. So in a system design interview, whether you are doing it online or where there will be a time when we'll be doing it person to person as well in face. So you should always have these in scope requirements in a visible place, because this will be your reference doc during the interview. So from these functional requirements, we can identify the kind of APIs we want. Okay, so let's see. We will need some API for upload. We will need some API for view, download. We will need some API which shows us news feed. We will need some API where user can choose to follow another user. Right. So coming up with API design is a very simple scenario if you have the clarity of requirements in your mind. Now, in case of upload photo, again, so generally when you are doing it in first pass during the initial time of interviews, always come up with the parameters which appeal to you on common sense. Do not spend too much time in addressing all the corner cases and edge cases. You can also give this disclaimer to interviewer at the time that, hey, are you comfortable if I go with the general and common parameters for the APIs, and maybe we can revisit them when we want to do a deep dive. So it shows that you are approaching your problem in a very structured and systematic manner instead of spending too much time on one piece without being asked. Okay, so for APIs, yeah, so the first one is upload photo. So of course, when a user wants to upload their photo, they will send some kind of user ID. Then they will send some kind of the location of the photo they want to upload, and maybe some timestamp. And then our system is going to give a response that it's success or fail. In case of download photo, user can send some kind of user ID, photo ID, and requested resolution. And then we will return back the photo URL. There could be application for download photo by user ID where I'm trying to find the particular photos uploaded by Justin Bieber. In that case, this kind of API can be there. Then there can be an API for getting the feed, right, where the system sends. So this will, let's say this is from the browser, right? User's browser. So browser will send the user ID, the timestamp at which the request is being made. Then it will send the page size. So why page size is being sent? Because the devices could be of multiple types, right? It could be a browser on desktop. It could be a mobile app. It could be app on iPad. So they all have different kind of resolution requirements, and they all have different kind of real estate. So the page size has to be dynamic. and then we send a continuation token. So this is for paging. And what system returns? System returns the list of newest post from the user follows. Right. So let's say the user is A and user follows B and D. So in this case, the system will send an array where the post from B and post from A will be put in that array list. And whenever this let's actually expand this. Okay, yeah. So I was discussing how the response is being sent. So what will happen is the system will send an array where each object will be that photo ID, then it is of which user. So in this case it could be A or so this guy is following B or D. Right? So in this case it will be B or D, and some other additional parameters could be there. Yeah, actual URL would also be there. Right? So in this way, this array will be sent, and then there will be the photo ID of this last element. This will be used as the continuation token. Remember, we talked about the continuation token in the last slide, this one. Right? So this continuation token is the last photo ID which was sent. So now what will happen is that in next request, we will send the same API request, but this time continuation token will be this photo ID. So when we will search in the database, we will say that search by all the params and photo ID should be more than this continuation token. And limit the page size. So this is how pagination will work. Yeah, and then another important aspect is that how this array is going to be sorted. So it is going to be sorted. So it could be sorted on the basis of newness, like ordered by time. Okay. Yeah, so we discussed the APIs, and now let's move to finding major components. Okay, Bharat is asking, sometimes I see photos dynamically updated as how is this achieved from API and system design perspective? Yeah, so actually on the front end JavaScript, if JavaScript is being used, then generally when you scroll down, so scroll is an event, and that event will trigger a call to backend that we need more photos to be filled in here. And while you are scrolling, that backend call completes and you see the results there. Or the system could be smarter and system could fetch multiple pages in advance, 2 or 3 pages of photos in advance. And whenever you scroll, the next set of 2 or 3 pages are downloaded in advance. So you can actually go on your Chrome and click on advanced options and then see the network activity and try to do scroll. You will see that how API calls are being made. How it is determined, number of photos to be fetched, Yeah, so that's what this is uh, this is similar to this one only, the page size that we discussed here. So page size is that how many number of photos will be downloaded. So it depends on the type of device you're using. Okay, so I'll mark it as answered. Yeah, maybe we'll come back to that question. Find the major components. Okay, so we move the more exciting part, that how do we find the major components. Hey, by the way, just a quick check. Is the level of my voice okay? Or should I be more loud? Maybe don't put it on Q&A, please. Put it on the chat box. Okay, perfect. It's okay. Okay, thank you. Thank you, everyone. Okay, so we find the major components now. How do we break down ambiguous requirements into components? So whenever you jump into this step, this is the question that you have to answer. That you have these nebulous, ambiguous requirements, and how do they map to a real system? The actual function, actual components. Right. So if we go back to the requirements, as I mentioned earlier, that our functional requirements are the North Star. Right? So they should always be in your sight. So we see that we are talking about managing content and we are talking about discovering new content. These are the two main things that we are talking about. Okay, so that means we see two systems here, two independent systems, one for managing content and another for discovering new content. It's managing photos and discovering content. So let's say we have one service called as media service. It could be photo service, media service. And this service is taking care of the upload, download, and searching of photos. Of course, we said that searching of photos is not in scope. So let's say in our case, it's taking care of upload and download. And then another one is the feed service for discovery. Okay, so let's move to the next part. Now from the previous slide, we see that media service is taking care of upload and download, right? Now, this is generally a good pattern to keep in your mind, that in most of the cases, or majority of the cases, the separation of read and write is a good practice. That means the system which is taking care of the reads and the system which is taking care of the writes, if we separate them out, then it makes our system more scalable. How? We will see in the next slide again. And especially when you are designing some kind of social networking aspects, at that time this becomes very, very important. Because for social networking websites, Read load is 1,000 times of write load, or it could be even more than 1,000 times. Because imagine that one tweet of Justin Bieber is read million of times. So this is the one aspect, that the scale is very different for reads and writes. Secondly, read operations are expected to have lower latency, because majority of the users are coming to do reads. They are just scrolling on their apps. So low latency. And the third part, that the upload is a slower operation compared to a view operation. And because when you are doing upload, you could be uploading a 10 MB high resolution photograph, irrespective of your device type. But when you are downloading, at that time the backend will ensure that based on your device type, the photo's size is optimized. So that's why upload are slower compared to the view or download operation. Okay, one question: shouldn't we mention all the services such as then dig into the finalization? Yeah, of course, we should do that. And so view, we have already identified that view and post are in scope, and we are saying the like and follow and comment service are not in the scope. So generally view and upload, these are the common themes of doing deep dives when these photo app and these kind of interview questions are asked in interviews. And follow service, we will talk about follow service, but you will see that it's very simple. So like service and comment service, we are not keeping in the scope. But yes, in your interview, you have to. So in your interview, actually, like we talked about in the starting, that search is not in the scope. Maybe if you discuss with your interviewer, maybe search is also in the scope, right? And in that case, your interview will go on a completely different path of search. So that's why you should be master of all these common systems: how to generate feeds, how to do reads, writes, how to do search. Once you know all of them, then you can have a discussion with interviewer and you can go on any path. Yeah, Bharat. So if the user is so the retries are generally this is a good consideration, and generally these considerations are from front end, from the client side, the app or the browser, and generally so they are not in the purview of backend. Because if logically, if you see that if front end is not successfully able to send 10 MB photograph to backend, what backend can do? Yes, you can go with both the approaches. So if we you can identify the system first, and then you can find APIs, or you can find APIs first and then systems. So once you work on multiple questions, once you work on multiple systems, then you will develop your gut feeling that what comes naturally to you. Even in like if I talk about me personally, actually I think about the database schema first, being from the old school. So I think in terms of database tables, and once I know that okay, these are the 4 or 5 database tables in front of my eyes, then I'm able to connect all the dots. that how what APIs are going to look like, how my microservices are going to look like. Yeah, so you have to identify that what kind of approach works for you. So that's why you need to do a deep dive into a lot of systems. Okay, so yeah, so in the previous slide we were talking about that how reads and writes have different requirements, right? And then we said that uploads are slower because it could be that the user is trying to upload a 10 MB high resolution photo from a very poor network. So in this case, what will happen is that, let's say if this is our media service, and these are the users who are trying to upload the photo, and everyone is trying to upload some heavy photos on a very poor network. Then these uploads will take time to finish, and we can have only finite resources for handling these uploads, right? So that means, just let me put it on a different slide. Right. So this is the media service, okay, and we have seen that there are two functionalities of media service. One is the upload, another is download, right? So what we are saying is that if uploads start taking a lot of time, right, if users are uploading heavy photos, then what's going to happen is that these connections will keep in the system. They will just keep opening and they will stay there. Right? And when these resources are hogged by the upload, then we will see that for downloads, we are not getting enough resources. And then these users who are trying to download, they will start getting errors. They will start getting 503 kind of errors, that their request has been rejected completely, or they will see very high latencies. So I hope you clearly see that how upload is impacting the performance of download here. Now similarly, we have the upload API and we have the download API. Now, and we also know that the download is the main feature of our service, because majority of the users are doing the reads operations. Now, if there is a bug on the upload API, let's say some developer has introduced some bug unintentionally and it has been deployed in production, and this is the both upload and download are running on the same server, right? In that case, download API will also be impacted. And the third thing that we have already discussed, that the scaling requirements are different for upload and download. Right? Imagine celebs posting pics after Oscar award. Right? So reads would be 1,000,000 times compared to writes. So scaling requirements are completely different. What does it point to? It means that we should have separate services for read and write. And then there is another advantage also. We have already discussed that our system is okay with eventual consistency. So what can happen is that our upload service can write to the primary database servers, and download service could read from the replicas of database servers. Right. So that means we will have 3 microservices: upload service, download service, and feed service. Okay, so let's do a deep dive into upload service. So generally, how upload flow will look like. So user logs into their device and they say that they click some button that I want to upload photo. Now the connection is established from the front end to the back end, and bytes start getting transferred over the network from the front end to the back end servers. Right. And when the backend servers, they receive those bytes, they will save it on some storage layer, because we are saying that we want reliability. Right? So we will have some kind of reliable storage layer where those bytes are actually being transferred and copied. Okay. What's naive about this approach? The naivety lies in the fact that we are making multiple network calls here. From the front end to the back end, actually back end compute, and from there to backend storage, and then all the way going back the responses. Right? So we have multiple network calls here, and when you aggregate all the time spent on these network calls, it means we have higher latency. And another thing is that the user also keeps on waiting till the upload is complete. Right? So user will see some kind of the spinning wheel, that it's uploading, right? So how do we optimize it? The problem lies in the extra network calls that we have. Right? What if we could store it directly from the front end to the backend storage? And that would eliminate the extra network calls. So how do we do that? So when user hits the upload button on the client, let me write it here. So this is the app user, right? And this person has invoked the upload API. And this is our backend system, where we have upload service, and we have the storage here. So at the first time when this upload API is hit, what our upload service does is that it generates a URL which represents a temporary and secure connection with the storage engine. So what happens in the background, that this person talks to this person. Of course, authentication and authorization will happen. We will not allow any person to talk to our systems without any kind of validations, right? So this is implicit that this request is received by upload service and it has done all the due diligence and it has found that, okay, user is valid. Then upload service will go to storage layer and it will ask that give me a connection over which this user can talk to you directly, and this will send a URL, and that URL we will see the properties of that URL, and this will return back that URL. Okay. Now what happens is that this upload API starts uploading the bytes over this URL directly. So this is the fifth step. So over the public internet, this app user starts uploading the photo directly to the storage layer, and that URL, this URL. So this URL has some authentication tokens. It has a window also, time to live window, that for how much time this is applicable. It can have bytes limit also, that how many bytes can be uploaded using this URL. Just the mechanisms to ensure that this URL is not abused by anyone. Right. So in the fifth step, we can see that network calls are eliminated. Extra network calls are eliminated. The network hop to the upload service is eliminated. And what's happening is that the app user is directly talking to the storage layer, and it is freeing our upload service also from the extra requests. And once the upload is complete from the client, it will send that URL to the backend server, again upload service, and it will say that we have finished the upload, and backend server will save this information that on this particular storage location this photo has been uploaded. It's for more internal details. You can see these using signed URLs. So how secure connections, by secure connections we mean HTTPS. Right? So how secure connections are established, how they have a lease, that means how they have a time to live, a validity period, and how they can access only a specific storage location. Okay, let's look into some questions. Yeah, so Amay, I think your question must be answered now, that how user is sending the signed URL, how the user is sending the URL to the upload API. Right. So I'll mark it answered. Is there going to be a specific discussion about how to scale systems for celebrity members? Yes, Asim, we will talk about it. We'll keep it open for now. Can we just write to cache and then commit to DB periodically? Reads can read from cache. So Bhanushri, the answer lies in the requirements. Our requirements say that our system should be reliable. Right? Imagine you uploading photos to Instagram and then after 5 minutes Instagram says that I don't know where those photos are gone, and you trust Instagram, so you have also deleted those photos from your mobile phone. Yeah, of course, if you can provide guarantees on cache layer that you will not lose the cache anyhow, then you, by all means, you can go for that design also. But it would be an overkill. Yes, all the connections are over HTTPS. Once a user has logged in, all the communication from front end to the back end will happen over secure connections, HTTPS. In case of direct uploading to storage DB, how caching will be handled? So caching is a separate function, right? First, you have to upload the photos. Once the upload is finished, then you will look into caching. And again, caching, we are jumping guns here. Right? We will see the caching later on. Will it not take more time to write to storage, and should we keep the user connection open until it is? Why it will take more time to write to storage? Yes, the connection will be open. User connection will be open. Of course, it has to be open. Otherwise, how without the user connection, how user can upload photo to backend, right? So connection has to open. The best thing we can do is that we can minimize the time of that connection being open. So that's what we are trying to do with this mechanism, where we are providing the access to the user directly. All the storage are hard disk in this world, Sarita. So if you look at the underlying systems, everything is hard disk. Yes. In many cases now, we have come up with SSDs where latencies matter more instead of the old-fashioned spinning hard disk. But still, if you look at the underlying layer of any kind of cloud storage, whether it's Amazon S3 or Google Cloud Storage or anything, they are hard disk. The question here is, where do we do compression? Because compression technique and encryption both are important factors before storing. The compression could be a point of discussion. Sorry about that. Compression could be a point of discussion, but this is something where you are optimizing before you have even made the system. So if you're talking about the caching and compression, these things at this moment, then you are over optimizing. Not over optimizing, you are pre-optimizing the system. Right? First, we have not even built a system till now. Like we are just come up with we have just come up with upload service till now. We have not even talked about download service. We have not even talked about how we are going to generate the feeds. What happens if client loses connection to server after uploading photo using the signed URL? Yeah, so in that case, Nikhil, we can have these information saved in session information. And whenever the connection is reestablished, that session is carried over from that session data, which is stored on the user's app or user's browser, and from there it is resumed. So similar to how your cart is shown to you again, right? Even if you add some product to the web to Amazon, and after 2 days you come to the same website, you see that those products are still in the cart. Is it possible to provide geolocation storage close to user to reduce it? Again, Srinivasan, we will talk about these things, but you will see that these are just a very logical extension and not a very detailed discussions. And you will see them why. And if we talk about geolocation storage and these things right now, they are pre-optimizations. But they will be covered. So this is how you should approach your problems in interview actually. If you start thinking about compressions and caching and geolocations in the very starting itself, then you are introducing a lot of complexity in the system from the initial parts. And there is a danger that you can just get trapped into those complexities. Of course, yes, the only thing is if your interviewer specifically asks you at that very point that, okay, tell me how you are going to do geolocation storage in the very beginning of the interview, then you have to talk about it. Exactly, Asim, exactly. Geolocation, caching, CDNs. So you don't go in depth in during the initial phases of the interview. Right? Let's say you are a software engineer, right? And I come to you as a client that please design. I'm just using an analogy here, and I come to you. By come to you means I'm talking about a generic person here. Right? So let's I go to some generic person XYZ, and I tell them that please design Instagram for me. Now, even before designing Instagram, right? Even before coming up with all the basic requirements that how upload service is designed, how download service is designed, or how feeds are generated, if they just talk about that how amazing caching they will do or how amazing geolocation supports they will provide, right? Then would I trust that person? My trust in that person will only be established once they show me some MVP, the minimum viable product. Once they have at least some foundation skeleton, then only we can talk about putting some more ornaments on that thing. And remember that interviews are generally 45 minutes to 1 hour. And out of that, 5 to 10 minutes are reserved for the initial pleasantries and the initial communications, and at the end for some questions that you may have. And so effectively you have anywhere from 35 to 45, 50 minutes. And you have already seen that till now we were just discussing the requirements. We have just come up with upload service till now, and 1 hour has just gone by. Right. So yeah, so please do not engage yourself in a lot of complexities right from the starting of the interview. Yeah, of course, these things, if they come to your mind, you can, what you can do is that you can save some story, you can save some space on your document or whiteboard, anywhere you are solving it. So you can keep you can say that this is my parking lot, right? And then you can say that, oh, interviewer, I just thought about it. Okay, maybe we need compression here also. We'll talk about it later on. Okay, yeah, I think that this system is read heavy, so caching is a very important requirement. So let me put it. We will talk about caching also later on. Okay, what was the, yeah, I think then you can ask interviewer, okay, do you think that users of our system are going to be just from a specific location or from all over the world? So chances are they will say yes, they will be from all over the world, right? Then you can say, oh, okay, then I think geolocation is also a very important part. We can discuss about that later on, right? So you can keep noting those things in a parking lot kind of area, right? This shows that you are approaching your problems in a very systematic way, not in a haphazard way. And that also tells your interviewer that you know your stuff, and you can always come back to these points later on. Are we not talking about bottlenecks before finishing and we should yeah, could be Nikhil. It could be. So I don't have a very strong answer for this. For me, it depends on the kind of backend experience. Right? So if the interviewee, the candidate is an experienced backend engineer, then they would identify in the very starting itself that the just a second. Yeah, they would identify in a very small time that they need to have read and write services separately, and they will also identify very easily that why the upload approach is a naive one and why we need more optimized one. Because I'm explaining here, it takes a lot of time, but when you are in an interview, it just happens in a minute if you know this stuff. Right? You can say that, okay, this is how the upload is going to look like, and then you can say, hey, by the way, I think we can use signed URLs here to make the uploads faster. And most of the time, it's going to be a very high level discussion. Right? So that's why I've put it here. What is the signs of strong and weak backend engineer instinct that can be easily judged during interview? Asim, this is a very meta level question. Maybe you can take it up with the specific IK mentor, because still we have so many things to cover. Maybe we'll come back to it later on if we have time. Agua Raman, sorry if I'm pronouncing the name incorrectly. Can you please do not post multiple questions? You can always add comments to your existing question. Does signed URL help increase the speed? Yes, we discussed that already, right? How it is decreasing the number of network hops. And once the network hops are reduced, ultimately your speed will increase, your latencies will decrease. can we make it async upload? Even if we make it async upload, there has to be some kind of connection, Srinivasan, right? From the front end to some backend system. Right? If I want to upload 10 MB photo, then that 10 MB photo has to make way from my application or from my browser to some other system, right? So till the time that transfer happens, there has to be some kind of connection. I hope that's clear now. Yeah, Sim, please do not. Yeah, you can send it on chat maybe. Okay, thank you so much. Okay, let's take a 5 minutes break. I need a break. I'll see you in 5 minutes. Okay, so let's start now. Okay. Yes, I thank you so much for that information. So yeah, so client side compression is something that is out of the purview of backend, right? Geo proximity, of course, we will talk about it in the end. We have the section where we address the bottlenecks of the problem, and preloading is something that I mentioned when a question was asked that how the images are loaded dynamically, right? So at that time I mentioned that even before the user scrolls to the next page, so let's say the user goes to the page 2, at that time only we fetch the photos or page 3 or page 4, so that when user goes to page 3, it is a very seamless experience, right? Okay, thank you for that information. Let's move to the next part. Okay. Okay, so we come to the another interesting aspect about the metadata. So in the last point here, we said that when the upload has been completed from the client to the storage layer, client sends the storage location to backend web server, and backend server saves this information. Right. So what is happening exactly? Okay, so we saw that the number 5 here is that bytes are being uploaded to the storage layer. Right. Then there is once that upload is complete, the 6th step is there, and this 6th step says that the upload is complete, and this is the photo URL. Right. This is the photo ID and this is the user ID. So this kind of information will be sent. This kind of information will be sent to the upload service, and upload service will store that information. And this information, this data is actually something that explains the underlying data, right? So the underlying core data is the actual photo object that has been stored here. Right? So this is metadata. Right? Now the question comes that should this data, core data, when we say the core data or just the data, it means the actual photo objects. and the metadata, should we keep them on the same storage server or we should store them separately? Right. So the good design practice, system design practice, is that they should be separately stored. Right. Why? Because it is quite logical if we do a deep dive. First of all, we can see that the nature of data is different. Right? This photo object, right? This is a binary large object. This is a blob. Whereas the metadata, it is not a binary large object. It is just a collection of some values, small values. Right? So the inherent nature of data is different. Then the need of scale is different. First of all, from the storage point of view. From the storage point of view, we can see that the binary large object, these photos, it is going to be a huge data requirement. Right? We have already seen in the previous slides that it is 40 petabyte for 6 years. Whereas the metadata storage requirement would be much less. Right. And consistency requirements are different for both the scenarios. Right. Now again, this part, we'll come to it. This part we'll come back to it when we choose the database for metadata. We'll come back to this. Right, so we have seen that the data storage layer for the actual photos and the data which explains that where those photos are uploaded on the storage layer, they are different, right? And we will revisit these things again when we are choosing database for them. Then again, they will become even more clear to you. Okay, now let's do a deep dive into the download service. So we have talked about upload service till now. Now we'll talk about the download service. So we established that we have a separate object storage and metadata. Now how this download flow will look like. So first of all, it is going to be a synchronous call, right? Because user expects the photos in almost real time. Almost real time, remember we said that it should be 100 to 300 milliseconds. Right? So in almost real time when they send a request. So the flow looks like this. So user requests a photo by sending photo ID in the request. Of course, with the auth token and user ID and those things. Then download service accepts the request. It makes a call to metadata storage, which is a separate storage layer now. And it will get the actual location URL of the photo based on the photo ID. And then it will return the URL to the client along with some auth information. And again, similar to the upload flow, the client here will make a direct secure connection to the storage layer. So client creates a temporary and secure connection to the storage layer and downloads the photo directly from there. And once that download is complete, the secure connection is terminated, or it could be terminated when the time to live has been exhausted. Yeah, if not, then it will automatically expire after a threshold. Can you elaborate on synchronous call in this context? Sure, I will. So, why synchronous call? Right? So, when you open your Instagram app, and let's say you want to see some photo, so you click on that photo. So once you click on that photo, you expect the system to show that photo instantly to you, right? So what will happen is, so this is the user. User says that show me photo ID 123, right? And your natural expectation is that you should see this photo in real time, right? So what will happen is that a connection is established with the download service. Okay, so that means a HTTPS connection is established. So let's say this blue line indicates that this is the secure connection that you established with the service. Now, synchronous call means the download service will fetch that photo for you. In this case, the photo URL actually. And on the same connection, it will give you back the response that this is the photo URL that you are looking for. Right? So it's happening on the same persistent HTTP connection. So this is synchronous, where you are guaranteed that if the backend systems are working optimally, then you will get an answer back in 100 to 300 milliseconds. And we'll see later on when we start using the caching systems, you can bring this latency down to single digit milliseconds. You can answer these things in 5 to 10 milliseconds also. So, and what if we had asynchronous? In that case, what would have had happened? That your request, let's say your request was download API for user 123, and your request was for photo 123. Now what would have happened is that this request would have gone to a queue, because when we talk about asynchronous call, those requests will be queued somewhere, and this blue arrow that we had, right, this connection that we had, that will be broken. That connection will be terminated. And once this request goes to the queue here, let's say your request is here, it may take some indefinite amount of time to get fulfilled. Of course, if your systems are working fine, or if you don't have very high load on the system, this request can be answered in a very small time. But it cannot be a predictable answer. Sometimes it can take 100 milliseconds, sometimes it can take few seconds also. So you cannot guarantee that answer will be returned in almost real time. So we have seen in the functional requirements itself, in the non-functional requirements itself, that it is a big requirement for us. So that's why this call has to be synchronous. It cannot be asynchronous. I hope it is clear. Yes, Bharat, we will talk about caching part. Don't worry. Okay. So let's move to the next part. Okay. Yeah, what is a photo ID? So we talked about the photo ID here. Right? So in most simplistic way, it is simply an auto increment ID, which is generated by a database and assigned to each photo, each unique photo by a user. Right. And how these photo IDs are generated? So we can have some kind of ID generation service, which ensures that these IDs are generated in a fast way and in a very highly available way. So again, in this photo sharing kind of interview, this ID generation service is not going to be the focal point, but this is a very critical system that you should master. And URL shortener is a good starting point. If you have a good knowledge about URL shortener, then this is similar to that. And you can also read about Snowflake system by Twitter. So how tweet IDs are generated. So Snowflake is the backend behind that. So you can read about that. And actually, I have a slide for this. Maybe if we have time in the end, we can come back to it. So we have talked about upload service. We have talked about download service. Now let's look into feed service. Okay, so feed service, let's see that what is the basic requirement for feed service. That our system should be able to fetch the latest or popular, or it could be a hybrid of latest and popular. Yeah, the algorithm could be tweaked in such a way that you have some weightage for the latest and some weightage for the popular. So you have some kind of decay algorithms where with the time the importance of a post decreases, but if it starts getting likes or starts getting more views, then that decay is offset. So it's that algorithm there are some hybrid algorithms for this. So we will fetch the latest or popular or hybrid top N photos from each person that user follows. Right. So there are two important aspects that we are fetching these top N photos from each person that user follows. Yeah, so let's see the flow first. Let's try to understand the flow and the approach. So when a user opens her feeds widget, right, on the app, or when it is refreshed, the front-end client makes a call to backend feed service to get feeds. So we saw that there was an API for feeds. So that API will be called. That API will be invoked. Yeah. And the separate feed service that we have, it will accept the request, and then it will we are talking a bit of bad planning from my side actually. So we are talking about the schema here, user follows table, but we have not looked at the schema. So shall we do this thing first? Let's talk about the database, choosing the database and the schema, and then we can come back to it. So this is what we have discussed till now. So we have the user talks to the upload service that I want to upload a photo, and then they get a signed URL, and then they upload using that signed URL directly in some kind of object storage, right? and another user who wants to download, so they send a request to download service. They get a signed URL and they download it using the signed URL, and that information is persisted in the metadata database, which is a separate one, and user gets the feeds also from the feed service. This arrow is missing here, so it should be here. Okay, so this is a high level design that we have discussed it now. Yeah, the step 4 is that, sorry about my font here. So step 4 is about the choosing the database and the schema design. Okay. So there are 3 things which are highly correlated. One is the functional requirements. From this you derive the APIs, and from them the tightly coupled thing is the schema. And this the schema for metadata, because of course the photos are going to be binary large objects. They don't have any schema, right? So this is the schema for metadata. So again, if we look at the functional requirements, from that we can derive that what kind of tables we will require. Of course, we will require a user table, and it can have ID, the user ID primary key, the name, email, creation date, these kind of, and then there could be 50 other columns as well. And but at the common sense level or at the bare minimum level, these are the columns that will be needed. Then for a photo, what things could be required? The photo ID, user ID, the URL, so the actual object storage location where it is stored, when it was created, what is the name of the photo, the title of the photo. Right? So we have user and we have photo. Then on any application, this is a very common thing that you want to see the photos of a specific user, like the photos uploaded by Justin Bieber or photos uploaded by your best friend. Right? So for that kind of scenario, you will have this kind of table, user photo table. So this is the primary key, the ID for the relationship, and this is the user ID. So user and the photo. Right? So let's say, so how this will look like. So there will be ID, there will be user ID, there will be a photo ID. Right? So let's say there is a user U1 and that person has 3 photos. Okay? So it could be like 1, 2, 3, some 2, 4, 5, 6, 7, 8. And this will be the row number, row ID. Okay? So this is how user photos will look like. And then the user follows table. So in this case, earlier we talked, right, that user A follows B and C. So in this case, we will have some kind of A, B, and A, C. This kind of relationship, this kind of data. Okay, so now we come to the interesting part. The part where a lot of discussions generally happen. How do you choose the database for your requirements? Right. And I have done a class exclusively on this topic. It was a 3-hour long class. If you have not seen, please do see it after this. It will answer a lot of your questions. In that class, I have covered a lot of use cases also, that which database should be chosen in which use case. How is user photo different from photo? So it is different, right? So when you want to when you want to see that which photos are uploaded by a particular user, right? So in that case, that kind of query can be easily answered by this setup, by this table, where you have the user ID to photo ID relationship. Yes, if you can also do this thing. I see your question. You can also do this thing that you can have index on user ID and then you can query on this. So you can do that also. Right. So, but generally, what will happen is that this photo table is going to be very heavy. Why it is going to be heavy? Because there can be multiple rows for this table. Multiple columns for this table. Right. And so you would like so in that, for that case, we can have this kind of table. I'll let me come back to this point. Once we have chosen the database, then again we can talk about it more. So choosing database for metadata. So should we go for RDBMS? We should not go for RDBMS because we do not need any kind of transactions or complex joins here. So therefore we can ignore RDBMS. Okay, then what other choice do we have? Okay, let's look at the type of data, how the data looks like. So we talked about the user photo table, right, where I showed the table like this, that user 1 has these photos and then they can be stored as multiple rows. Or user table could be there where we have this type of thing. So if you look at these data, these are actually key value data. This is key value data, right? So where key is, let's say in case of user table, it is just a user ID, and the values are just a collection of multiple columns. Right? The name of the user, email of the user, when it was created, this kind of information. Right? So the key is user ID and the value is the collection of all these columns. Right. So first thing we have said that we do not need any kind of transactions, right? Transactions not required, right? So we have said that no RDBMS is required. Second thing we have said that the data format is like a key value format here, like this. what does this tell us? This tells us that we need a columnar database. That means, or as you call them, column-oriented database. So we need the very popular that we need a Cassandra-like systems, Cassandra, Bigtable, DynamoDB, this kind of database here. Because once we have this kind of database in the place, another good thing about them is that they can provide us replication. They can provide us replication and they can provide us sharding built in. We will look at sharding also, that what should be the preferred approach for sharding. We will discuss this. So with this choice, our system becomes highly available and reliable. And another thing which comes from the requirements, right? We agreed that consistency is not a key requirement. So our system is okay if it is eventually consistent. So in that case also, this database performs very well. This column-oriented database. Yes, so we mentioned this in the previous one, right? So Cassandra or Cassandra-like database like DynamoDB, Google's Bigtable, all these are similar databases. Isn't the KVDB like Redis can be used instead of Cassandra? Just curious. I have discussed this in detail in the choosing database prerequisite. But again, Redis is a caching solution because it's because the most of the data is stored in the memory, and these are very expensive solutions. So you use them basically for caching, not as data storage. So we will talk about it when we talk about the caching part. Okay, let's see the choice of database for photo objects. Right, so these are binary large objects, these are blobs. Right, so so for these kind of data storage, the distributed file storage are the best options, like SDFS, Google Cloud Storage, or AWS S3. And these databases provide us replication so that the data is stored reliably. And then they also provide multiple replicas also, which helps which helps us to scale our system horizontally. Then there is another good thing about these kind of file storage systems. Like if you look at the internal design of S3 or Google Cloud Storage, actually I recommend this paper. On GFS, on Google's file system. This is a very good read. So actually these servers, if you look at them, they are just basically Linux servers, where these photo objects are being stored as local files. And so and And Linux also keeps a buffer cache at its level. So let's say there is a server where Justin Bieber's selfies stored. Now many people are asking for this. So of course we will have a caching layer at this level, but if we go down at the S3 level also, then Linux provides a buffer cache here. So Justin's selfie, which is being queried again and again, this will be cached by the Linux system, and then we get this kind of caching automatically. Okay, so we discuss about the metadata, that how we need a column-oriented database for this, and how do we need blob storage, the distributed file storage like S3 for this. Okay, coming back to this discussion about the user photo table. So when so this kind of query will also be very frequent in the system, that you say that for this user ID, give me the photo IDs. And if you know about the column-oriented database, then in that case, this supporting queries on this photo table would be a difficult thing. So in that cases, what you do is, in case of column-oriented databases, is that you find out that what kind of query patterns you have, and to support those query patterns, you create specific denormalized tables for that specific use case. If not, we can come back to it again later. Okay, thank you. Is there any discussion of query, schema design, sorting? Yeah, so any discussion of queries? So queries are, so from they are here from the functional requirement itself, right? That we have discussed. We have already understood the download path, the upload path in detail. Right. And this sorting, Asim, you mean for the generating the photo IDs, or this sorting is in terms of the authentication? I'm not sure about your about the motivation of the question. Okay, Amma is asking, isn't the user ID plus photo ID can be the PK for user photo table? Yeah, so again, so as we discussed already, right? So we are going for column-oriented database, right? So in that case, it wouldn't be a possibility. So Asim, your question has been answered now, that photo ID and corresponding block data location can be persisted in some kind of distributed key value store. So that is what we are doing in this column-oriented database now, right?
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FAANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your 3 webinar slot today